Flux, the GitOps toolkit for Kubernetes. Agenda, GitOps architectures, Flux history. Why Flux? Reconciliation lifecycle. Getting started. Basic workflow. Sources and customizations. GitOps architectures. GitOps treats a Git repository as the single source of truth for what should be running in a cluster, reconciled automatically. If the cluster drifts from what's declared, a GitOps controller notices the difference and can correct it without a person stepping in. Almost every team adopting GitOps eventually chooses between a single unified tool and a set of smaller composable controllers. Any team running many clusters benefits from an architecture that scales cleanly as the number of applications grows. Wiring together deployment automation from scratch for every cluster doesn't scale. Monolithic and modular GitOps tools. A monolithic GitOps tool bundles source control, rendering, syncing, and a UI into one application. Flux instead splits GitOps into small, focused controllers, each responsible for one part of the pipeline. Monolithic Argo-Seed is single app plus UI, one API server, all the features bundled together. Modular Flux GitOps Toolkit Specialized controllers. Use only what you need. Problems with monolithic deployment tools. Single point of failure. One large application handles source fetching, rendering, and syncing all at once. Hard to swap out or upgrade just one part of the pipeline without touching the whole tool. Every team ends up paying for features like a UI it may not actually need. Difficult to compose custom automation like image updates without extra add-ons. Scaling one large controller, many clusters can concentrate load in a single component. Misses out on the flexibility of choosing only the pieces of a given team actually needs. The Flux GitOps Toolkit system. Desired state is declared as Kubernetes manifest, Helm charts, or customized overlays kept in a Git repository. The source controller fetches Git repositories, Helm charts, or OCI artifacts, making them available to other controllers. The customized controller and Helm controller then render and apply that content to the cluster. Other components in the toolkit: notification controller, image automation controller, image reflector controller. Flux advantages: splits responsibilities across small controllers, each doing one job well. Built-in image automation can update a Git repository automatically when a new container image is published. Runs as a lightweight API-driven set of Kubernetes controllers with no separate UI required. Scales cleanly to many clusters through a fleet management pattern. Multi-tenancy is straightforward since each customization can be scoped to a team or namespace. Backed by the Cloud Native Computing Foundation (CNCF) and the team that originally coined the term GitOps. Everything is a custom resource almost. One huge benefit is that in Flux, almost every part of the pipeline is expressed as a Kubernetes custom resource. A GitOps repository resource describes where to fetch source from. A customization resource describes how to apply it. Because everything is a native Kubernetes object, kubectl, role-based access control, and existing tooling all work against it directly. Composing new automation is often just adding another custom resource, not writing new integration code. This approach gives Flux feeling like a natural extension of Kubernetes itself, rather than a separate platform bolted on top. Sources and customizations. Git repository declares where Flux should fetch source from. Customization declares how fetch to source should be applied. Git repository.yml, a Git repository resource, tells Flux where to fetch application manifests from. Customization.yml file. A customization resource applies the fetch to source to the cluster on a schedule. History originated at ViewWorks, the company that coined the term GitOps in 2017 blog post. The original Flux, later called Flux V1, shipped as a single controller combining source syncing and deployment. Flux V2 was ground-up rewrite, splitting responsibilities into the specialized controllers of today's GitOps toolkit. Donated to the Cloud Native Computing Foundation, joining Argo CD, Kubernetes, and Helm. Reached a graduated status within the CNCF, reflecting its long track record in production. Why Flux? Composability, a suite of controllers instead of one large do-everything application. Kubernetes native, everything is a custom resource, so existing toolkit works out of the box. Image automation can update Git automatically as a new container images arrive. Lightweight, no separate UI or API server required to operate the core toolkit. Multi-tenant friendly, customizations scope cleanly to teams and namespaces. Backed by the CNCF and the team behind the original GitOps model. The source controller. The source controller is responsible for fetching and caching every artifact Flux depends on. Watches Git repository, Helm repository, and OCI repository. Resources for new content. Makes fetched artifacts available internally so other controllers don't each need their own Git or Helm client. Never point to different customizations at conflicting paths in the same source. Reconciliation can fight itself. Flux reconciliation lifecycle. Source controller fetch, customize build, apply to cluster apply, watch for drift reconcile. The source controller fetches new content, customized controller builds the manifest. Changes are applied to the cluster and Flux keeps watching for drift. Getting started with Flux. This leads us to the three commands that get a cluster synced. Flux Bootstrap. Deploy Flux controllers and connect them to a Git repository. Flux create source Git. Point Flux at a Git repository to fetch from. Flux create customization. Apply a path from that source to the cluster. Basic workflow. Reconciling, inspecting, and automating. Some call reconcile, inspect, and automate Flux everyday loop. Declarative. Commit to Git and the next reconciliation only applies what's different. Flux Git shows the status of every source and customization at a glance. Flux logs streams live reconciliation events straight from the controllers. Image automation can open a pull request the moment a new container image is published. Supports many workflows, single clusters, multi-cluster fleets, progressive delivery with Flagger. Works the same across any Kubernetes cluster Flux is installed on. Any questions? Thank you.